recorded video will be shared in e-learning. So please always use your e-learning. Okay, please check your e-learning before, if possible, prior to the next class. Check some. Okay. So this course, this course information for SEEU. So this is the code lah. Okay, I hope all of you can see clearly this what I'm sharing with you is now, what I'm sharing with you at the moment. Okay, which is the course information for SEEU 1002 or SKEU 1002. Okay, so the program name is Bachelor of Engineering Mechanical or Bachelor of Engineering Mechanical Automotive or Bachelor of Engineering Naval Architecture and Offshore Engineering. So basically this course is specially designed for mechanical school, right? School of Mechanical. All right, so the course name for this SEEU 1002 is Electrical Technology for Non-Electrical Discipline. Okay, so if you compare, basically this is like, you know, very light course design, specially designed for non-electrical discipline. So you should not feel very stressed lah with this subject, with this course. Okay, in this in university we call subject as course. Jangan confuse lah. Do not confuse So we call apa ni, subject in your class. I mean your probably when you did your matriculation or might be during your school, right? SPM session you call, for example, mathematical subject or maybe science subject. But here we call that as course. Okay. The credit hours is 2. So if you want to know the number of credit or credit hours for each course, basically it's appear at the end of the course. Okay. For example, here 2, right? So this the last digit there actually represents the credit hours. Okay, for that course. Okay, so it's carry 2 credit hours only. Okay. So this is the synopsis. Okay, synopsis for the course. So you will be introduced to the concept and theory of basic electrical engineering. Okay, and we will highlight the fundamentals of electrical engineering to enable students to apply simple electrical circuits in their work environment. Okay, so that this course will cover both DC and AC. Okay, so for the AC systems, we'll cover single and three-phase systems, and then you should also know how to analyze simple electrical network using electrical basic laws. For example, Ohm's law. I'm sure all of you know what is Ohm's law. Kirchhoff law, this one I'm not sure. Most probably yes, most probably no, depend on your background. And then currents and voltage divider, and this one I'm sure you know how to use it. Okay, current and voltage divider. Next is on nodal and loop analysis. This one might be new for you lah. Okay, and then you will be also exposed with a simple magnetic circuits, transformers, and also a little bit on introduction to electrical machines. So this course is very, I would say that it's very it's a fundamental course which enable you to apply simple electrical circuits. Okay, not only to apply but also to know about electrical circuits. whether you like it or not, okay? Whether you are non-electrical discipline or electrical discipline. So if you look around you, in fact, if you look on your PC or your handphone at the moment, you are actually dealing with electrical, electrical form of energy. Okay, nak you have to, you can imagine, yeah, your love or your life. You can imagine your life without electrical engineering or without electrical form of energy. Okay, so basically no electrical, of course no class lah nak cakap kan. No electrical, then you cannot have this online class. Okay, no electrical, no internet. So basically electrical is very, very crucial. Okay, very crucial for our, for our society and our life. Okay, the course coordinator is Dr. Muhammad Fadli Ibn Ahmad, my classmate when I did my degree here in UTM, Dr. Muhammad Fadli Ibn Ahmad. And then the course lecturers, so this is the list of lecturers lah. Okay, Dr. Ahmad Safawi, which is my guru, okay, my teacher. Okay, Dr. Ahmad Safawi. And then Dr. Moda Riza, my junior. And this is my name lah, Muhammad Junaidi bin Abdul Aziz. And this is my office, P07211. And you can contact me through this number, or you can email me. Be careful if you want to contact me, only contact me during office hour. Saya tak suka orang contact saya beyond office hour. Okay, beyond office hour means my me time and family time. Okay, if you want to contact, you call lah. Okay, if you want to call during office hour. Message pun sama during office hour. Unless you want to email me. So email me, no problem. You can do it 24/7. Okay. I hope you can respect my time. Alright. Tak nak serius-serius sangat. Your first class. Okay, this is the. I'm sure you have no idea what is this CLO, PLO, but we need to go through, this process so that you can appreciate the environment of teaching and learning in UTM. Okay, so this is the basically what is course information? Course information basically is it's like a summary of the course. Okay, the summary of the course, or what actually we are, that you need to know what is the objective of the course, the synopsis of the course, and then a detail on the what they call it, detail on the topic, weekly schedule. So you can see here lah. Okay, so this is the mapping of the course learning outcomes to the program learning outcome. So what is course learning outcome? Course learning outcome is the learning outcome for this course. Okay, so that is the course learning outcome, and the program learning outcomes is outcomes for your program. Okay, so every program is designed by the MQA, Malaysia Quality Assurance. So they have a series of PLO. Okay, so every university, they have to fulfill this PLO. Okay, the whole PLO must be covered by undergraduate course. For example, PLO designed for undergraduate course. So this PLO, of course, designed by university. And then this course learning outcome must be mapped to the program learning outcome. So that's every course, they have their specific PLO. And of course, every course, they have their own unique, mapping, okay, between the CLO and PLO lah. Okay, so for this course, it has two learning outcome. Okay, two learning outcome. So the first learning outcome, CLO1, is the description is about how to analyze a DC and AC circuit by using two basic electrical laws, which is Ohm's law and Kirchhoff's law, and three methods of analysis. So we're very focused using currents and voltage divider, and then nodal and loop analysis. Okay, so Ohm's plus Kirchhoff, and three basic methods, which is current and voltage divider, nodal, and also loop analysis. Okay, to describe their basic operation. So this is for non-electrical students. For electrical students, we have more methods. For example, superposition, macam-macam lagi. Okay, so for your case, we only focus on these three methods plus Ohm's law and Kirchhoff's law. So altogether 5 laws. No, sorry, not 5 laws. 2 laws plus 3 methods. Okay, so we're going to focus on only on these 3 plus 2 laws, 3 methods plus 2 laws. Okay, mapping to PLO1. So you need to refer to your PLO lah. Okay, different different program have their own unique PLO. So in I believe that SKE use different PLO as compared to SKM, Sekolah Kejuruteraan Mekanikal, SKM, we call it SKM. The weightage for this CLO is CLO1 is 60. Okay, and then this is the teaching and learning method that we use. Okay, lecture plus tutorial, and also class activities. So this is the assessment method. Okay, assignment which carry 10 mark. So later on will be weightage to 5% only lah. Okay, assignment 5% for this is DCL1, and then quiz 10 mark, 10 mark equivalent to 5% lah. Okay, 5% for total mark. Okay, and then tests, we have 2 tests. Okay, test 1 and test 2, so 30 plus 30, which is actually equivalent to 30%, 15 plus 50%. And then final exam, 40 mark goes to CLO1, which carry 20%. So altogether 60% for CLO1. So 60 come from this number, 5 plus 5 plus 15, 15 plus 20. Okay. CLO2 is about analyzed three-phase system. Okay, and then magnetic circuits and transformer by using basic electrical laws, and compare 3 types of electrical machines. So CLO1, you can say that for CLO1, we are dealing with electrical circuits, both DC and AC. Okay, but CLO2, we are dealing with three-phase system. Three-phase is also AC, but we focus on the three-phase system, and also magnetism, which involve magnetic circuits and also transformer. Okay, so the transformer basically is the application. Basically, it's come from magnetic circuits. Okay, come from magnetic circuits. You can design transformer actually from the magnetic core and circuits. Okay, so that is mapped to also PLO1. Okay, so for the CLO2, the assessments 10 mark, which is equivalent to 5 marks, goes to assignment 2. Okay, and then quiz carry 5%. Final exam, ini besar sikit. Final exam 30 plus 30. So 15% plus 15%. So 30% goes to CLO2 lah. CLO1 ni sikit je, 20%. Ini 30%. So you can see the weightage. Because of the CLO2, we will focus that on the second half of your study. Okay, in UTM, you can divide it into 2. The first half is basically for week number 1 until week number 7. Okay, and then week number 8 and above until week number 5 or maybe 14. So that is considered a second half. Okay, so the CLO2 will fall to second half. So that's the reason why we will not test Okay, your test 1 and test 2 actually come from CL01, goes to CL01. Okay, not CL02. Okay, so 2 will go 100% goes to assignment, quiz, and final exam only. No test for CL02. All right, so active learning, I'm not sure how to do the active learning here because of the number of students for this class is quite a lot. Berapa orang Let me check. Mana? 1002. Okay, ada 52 students, 52 students. What a lot. If we if we have a active learning in our class, maximum is 3 students per group. So divide lah, 52 divided by 3, banyak tu. About 17 group. Oh, penat. 17 group macam satu kelas pula. Anyway, class must go on kan. Buat je lah. Okay, so conducted through in-class activities. Okay, so I might, we need to form a group. Okay, and then I will give you a problem, so we can call that as the problem-based learning. Okay, so you need to solve it in your group, or might be a jigsaw activities, or maybe think pair shares, and that's all lah. Involve active learning. Okay, for chapter 1, DC circuits. Okay, so involve chapter DC circuits. So basically for this week, we're going to focus on voltage and current source, type of voltage source and type of current source, and then goes to Ohm's law. And after that, nodes, branches, loops, and Kirchhoff law. So all these terms actually refer to electric network, electric circuit network. Okay, nodes, branch, apa benda pula branch kan? Branch is macam pokok pula So branch and then loops, nodes. So make sure you understand all these terms during this week. Okay, because of this is your fundamental course for your electric circuits or electric network, how to analyze it. So I believe that it is very important to understand the term that I use in our class, that we use in our class. Okay, and then for the week 2, it's again still chapter 1 until week number 4. Still chapter 1. So week number 2 is about series resistor, voltage division, parallel resistor, current division lah. Okay, and chapter week number 3 about nodal and mesh analysis. Okay, and then continue to the week number 4. Okay, nodal and mesh. So this nodal and mesh is very, very fundamental. It's very important. Basically, this nodal and mesh analysis come from Kirchhoff current law and Kirchhoff voltage law. Benda yang sama je sebenarnya. Okay, so they extend the Kirchhoff current law and Kirchhoff voltage law. So they come out with the nodal and mesh analysis. So what is nodal? What is mesh? We're going to find out. Okay, this week. Okay, and then for week 5, we move to AC circuits. Okay, so week 5, 6, 7 until the mid semester. So that's for AC circuit, single phase. And after that, we move to 3-phase system. So what is single phase? What is 3-phase? So basically, the single phase and 3-phase is AC system. Okay, so this AC system, you can have single phase or you can have multi-phase. So why you need to know about 3-phase? So that will be revealed in the week number 9. Okay, so 9 and 10. And after that, we move to magnets and magnetic circuits, magnetism and magnetism. Until week number 15, which is introduction to electrical machine. Okay, and that's it. So that is the content for this course. Okay, so as I mentioned before, this is the assessment, quiz plus assignment. You carry about 20 mark. Okay. Assignment 10, quiz 10. Betul tak? Cek balik. Lupa dah. Betul. 5, 5, 5, 5. Okay, 20 mark for your quiz and assignment. Test. You're going to have 2 tests. Okay. Tarikh dah ada. Lupa lah. I need to check. Okay, the tarikh. Mana ada the date for your test. Kena cop awal-awal. Tak nanti berebut dengan lecturer lain. Sekejap let me check. Education. One minute cari tak jumpa lah pula. Ini minute meeting. Okay, your test 1 is on 23rd November. Sorry, saya share jap share. Stop sharing. Okay, let me share the date for your test. Ini test awak. Please take note. Tarikh ni. Itu tak penting. Siapa yang buat soalan tu tak penting. Yang penting tarikh ni. Okay. Saya dah cop ni tau. Jangan cakap nanti clash. Clash your lecturer that make it clash, but this is your first class, right? So I have privilege lah. Okay. To cop this apa ni this date. 23 dan 11 23rd. Okay, November 23 and December 28. Okay, so test 1 and test 2. Ingat tarikh ni jangan cakap clash, tak sepatutnya clash. Kalau clash minta ask your lecturer to to change the date. Sebab saya dah cop awal-awal dah. Okay. Selesai course information. So let's move to warm up lah warm up for your chapter 1. Kejap lagi ni nak habis dah. At 8:50 I need to stop. Why? Because that's common in UTM. Okay. It is stated on your timetable. Okay, your timetable stated that the class is for 1 hour, but usually it will end at 10 minutes before 1 hour. Why? Because you need to prepare for the next class. So for face-to-face macam tu lah because you need to travel, you need to move from one class to another class. So that 10 minutes basically is reserved for for preparation for the next class lah. Alright. Kadang-kadang terlajak sikit 5 minit macam tu lah. But it will not go beyond the stated time lah. Cakap 1 jam tu 1 jam lah. Tak boleh lebih. Lebih tu maknanya I'm not respecting the next lecturer. Okay. Sikit je ni bendanya. Sikit je, biar relax. Sekejap, lajak dah ni. Okay. So, as you can see here, that these notes prepared by Dr. Muhammad Fadli lah. Okay. So, I'm not going to use I have my own, but same, this is his course, so I need to respect him lah. Okay, so I'm going to use his name in my notes. I have my own, but that's one again because this is my first time teaching this subject to mechanical students. So first time takkan terus nak pakai nota sendiri kan. Ni tak respect lecturer lah. Okay, so I'm going to use his notes and I will add up with my my own notes lah kemudian so I will try to improvise his notes lah. Okay, later on, bukan sekarang lah, tak sempat. Okay, this is the content, basic electrical system. Okay, and then for this chapter, start with basic electrical system and then followed by electrical quantities and units. And then I'm going to introduce you what is currents, voltage, and the relationship with power. Okay, followed by basic electrical laws, which is Ohm's law, Kirchhoff currents law, and Kirchhoff voltage law. Okay, KVL and KCL. And then I'm going to introduce you series circuits and parallel circuits, and combination of both series and parallel circuits. Okay, and then voltage and currents divider rule. Okay, which is your methods, which is a very basic method. We consider that as basic method. Followed by the second and third method, which is loop and nodal analysis. Loop or mesh, we can call it loop or mesh. So what is the difference between loop and mesh? We're going to look in more detail in the next class. What is loop, what is mesh, and what is nodal. And next, on power, how to calculate power on electrical circuits. Okay, so this is the basic electrical system. So we know that electricity is actually a form of energy. Okay, so the examples of energy source. Okay, examples of energy source that creates or that generates electricity is hydro, coal, wind, nuclear, and solar. So as you can see from here, the source of energy is not electric. Okay? It's not electric at all. Okay, hydro basically is mechanical, maybe what they call it. Alamak, lupa dah. Hydroelectric which is it is not electrical hydro. So basically this hydro form of flow of water at high speed, and then it will turn the turbine. Okay, then that turbine will produce or generate electricity. So basically the form of energy is come from not from electric. Okay, so it's come from might be from any mechanical like hydro and wind. Okay, wind also from mechanical. Okay, and convert it to electrical. Coal and nuclear basically from heat and chemical form of energy. And solar is from solar irradiance, which is from it is not heat. Solar is a very special form of energy. It is not heat. Basically, solar it can be both. There are two ways to generate electricity from solar. First, using heat. Okay. Second is using irradiance. So the more popular is irradiance lah compared to heat. Heat ni basically we use on desert lah. Okay, it's very hot climates, and then they focus the solar. Okay, focus the solar creates heat and then convert it to electric. Okay, electricity. Okay, so as you can see here that the electrical system or the electricity actually is like the middleman. It's like a middle form of energy. Okay, so the source is not electrical, The N also sometimes, not sometimes, but most of the time, is also not electrical. Okay, so the source not electrical, the end user also not electrical. Okay, you can for example, the end user is like, you know, your lighting. Okay, lighting, apa lagi, your handphone tu. Okay, and then might be your aircon, air condition. So air condition is not electrical. Air condition is apa dia tu? What form of energy? Air condition. Heat. Might be heat lah, for heater. Okay. Apa lagi? Fan. Okay. The end user, I mean the load. Okay, fan basically is not electrical. Okay. So fan is mechanical. So we can see here that the electricity basically is like a middle form of energy. Not from the source, not from the end. It is in the middle. Okay, tengah-tengah. Okay. So the electrical system, what is so great about electricity is you can transmit energy. Okay, because the electricity is very easy to transmit. Okay, very easy to transmit, and you can transmit the electricity at high efficiency. Okay, at high efficiency rate as compared to other form of energy. So it's very useful to transmit. Okay, it's very easy to transmit, and you can transmit at high efficiency. Okay, you can transmit efficiently lah. Okay, so the electrical engineering actually is the profession concerned with systems that produce or generate and then transmit and also measure electrical signals. Nampak tak? Measure electrical signals. Not the N. N ni bukan. N basically is, you know, lighting. Benda-benda tu lah. Mechanical, fan, lagi. Okay. So, the N apa dia? The end user. So the load and the electrical load, mostly they are not electrical at all. Okay, so not electrical form of energy lah. Okay, so my question is there any, okay, is there any device or might be equipment that actually use electricity as the final form of energy? Ada tak? Ada siapa boleh cakap? Ada siapa boleh bagi tahu? Final end of energy tu is electricity. Ada tak?
Dynamo.
Tak dengar?
Dynamo.
Which has one. Apa dia sebut tadi? I cannot hear you.
Oh, sir, I said dynamo, sir.
Dynamo. Dynamo is electricity, but the N is not dynamo. Dynamo actually is generator.
Yeah.
Dynamo is generator. It's not N. Okay, dynamo basically, usually when we talk about dynamo, we use it for bicycle again. Betul tak? Apa ni? Apa tu? The machine used in ICU on the chest. Betul. That's correct. Sebenarnya tak banyak. Okay, dynamo is bukan dynamo is generator. Produce electricity for apa ni, bicycle lighting. So itu contohnya lah. Tapi untuk yang cakap tu betul lah for ICU. Apa lagi? Because that's used Tesla coil. What is that? Tesla coil. Itu betul lah untuk high voltage. That's correct. Tapi what is the purpose of that Tesla coil? Untuk main-main suka-suka mungkin lah kot. Okay, electric fans. It's correct. So tak banyak lah sebenarnya, tak banyak. Teaser. Okay, teaser pun yes. Okay, taser, sorry. Dia panggil apa? Taser. Lupa dah. Yang apa tu yang polis, basically polis in UK, they use electric taser tau. Dia tak pakai taser, dia tak pakai pistol biasa tu in UK. It is quite dangerous jugalah. But you can imagine lah kalau you buat jahat-jahat depan polis kan, you buat muka-muka nakal ke, daripada jauh dia tak buat apa lah. Because taser dia punya range very short. UK jarang-jarang dia orang pakai normal pistol or normal gun lah. So they're using laser. Apa lagi selain benda tu? Kebanyakan tak ada, makan sikit sangat. Apa mosquito net tu kan, apa tu racket mosquito tu ya juga. So it's very limited lah. Okay, banyakkannya most of them the load is not electricity, it's not in form of electricity. Okay, so what is electrical engineering? So electrical engineering is the profession concerned with the system that produce, transmit, and you can say measure electrical signals. Load jarang-jarang aja. Okay, semuanya mematikan orang adalah. Okay, mematikan orang ataupun menghidupkan orang. Like apa ni, nama istilah dia lupa yang guna kat ICU tu. Okay, and then the example of electrical systems, power systems, communication system, computer system, control system, and also signal processing system. So this is the examples of electrical system. Banyak lagi sebenarnya. Okay. So for the basic electrical system, so the source will provide energy for the electrical system. For example, it comes from battery for small appliances like your toys, the kid toys, and maybe big boy toys pun sama juga using battery. Okay, generator might be socket outlet, so that is the source lah. Okay, which provide energy for electrical system. Okay, so the load is what is load? So load actually is the element that absorbs the electrical energy supplied by the source. For example, lamps or the lighting lah. Okay, it might be conditioned. Okay, the next is transmission systems. So transmission system is a system that conducts energy or transfer energy from source to the load. Okay, so this transmission system usually involve conductor. Okay, so it can be wire, insulated copper wire, or might be aluminium wire. It can be insulated, it can be non-insulated. Boleh jadi dua-dua. But for wiring in your house, your wiring at factory wiring and such what, usually we use insulated wire lah for safety. But for transmission system, transmission line, we're talking about menara yang tinggi-tinggi tu, yang TNB tower tu, okay, transmission tower, that one use bare wire, maknanya tak ada insulation. So that's the reason why it is called, it is stated at the tower, okay, at the tower, high voltage, and then do not enter this area, blah blah blah, because basically it's using bare wire, tak ada insulation, no insulation at all. Okay, that's the reason why you are not suggested to playing around that tower and then playing kite ke apa-apa ke, so because of the high voltage. And then control apparatus permits energy to flow or interrupts the flow, for example switch. Okay, so that's the control apparatus lah. So this is the example of electrical systems. Okay, it's come from generator. So this is the generator, the source of energy, source of electrical. Okay, so generator, it can be a diesel generator. Okay, so the diesels produce or generate electricity. So this is the switch. Okay, so the switch will control the flow of electric energy. So this is a transmission system. Okay, this is a transmission line. Okay, and the lamp here is your load. Okay, so it's basic example of electrical system. And of course, most of us, in fact, saya pun tak ada, you don't have the generator. Okay, so we can replace this generator with a socket lah, TNB socket. But this is a very, for me, it's very basic electrical system that actually represent the whole complex system of electric power engineering. Kalau electric power engineering pula, okay, this generator should come from synchronous machine. Far away, might be from hydroelectric Kenyir ke, or might be from Tanjung Bin plant, which is electricity plant. Okay, so this generator replaced by that, Kenyir, for example, Kenyir Lake. And then this Kenyir Lake use hydroelectric to produce electricity, and this is the transmission line. Okay, so transmission line is very long lah, from Kenyir to Skudai, for example. Jauh tu, about 300-400 kilometers away. So basically that is the complete electrical power system. Okay, so inilah cerita dia. So we can replace it with this circuit diagram, a generator, and then switch, control the apparatus, and the lamp is the load unit. So this wire is the transmission system. Okay, so this is the example for power system. Okay, 1 minute, last one. Okay, so you can see here, it can come from, hydroelectric, Bakun ke, Kenyir ke. Okay, so we have quite a lot of hydroelectric actually, but Bakun and Kenyir is probably the largest one, the largest two of hydroelectric that we have in Malaysia. And of course, we have some more. Dekat Cameron Highland pun ada, just a small one. Apa lagi, Kuching, kat Sarawak pun ada, Sabah pun ada. We have this hydroelectric. But of course, the dam and the hydroelectric is small compared to Kenyir and Bakun. Okay, and then these produce electricity. Okay, and we use transformer to step up or might be step down. And in this case, usually this transformer, we use it to step up the voltage. Okay, so the electricity produced or generated from this hydroelectric, usually around 20 something to 32 kV, and then we step up the voltage. The reason why we step up the voltage is for transmission line, it's involved, long distance. Okay, so we know that by increasing the voltage, okay, when we increase the voltage, we need to reduce the current. So that's how it's worked. Power, you cannot, energy cannot be created nor destroyed, right? So what we do basically, when you increase the voltage, you actually need to reduce the current. Why? Because the power must be remain fixed. Okay, so when you increase the voltage, what happens is, we know that this consists of lots of conductor. So this conductor actually, it has some resistive element. Okay, so the reason why we increase the voltage is we want to reduce the losses. Okay, because the losses is equal to I squared R. Okay, when you increase the voltage, the current is reduced. Okay, and we know that losses is equal to I squared R. So when we reduce your currents, actually you reduce the losses. Okay, and then we have another substation. On this substation, actually it has some transformer, usually step down, and this is reduced to 130. For certain industry, they use 132 kilowatt. Okay, but before it comes to your house, you can see here, this is the process. Okay, 400 step down to 130, and then step down again to about 40 to 70 kV, and then reduce again to about 11 to 22 kV. So in UTM, we have our this so-called secondary substation, which is 11 kV. Ini kat UTM. Okay, and then before it is connected to factories and your house, basically we need to reduce again to about 400 volt, 415 actually, 415 volt in Malaysia. Okay, 415 volt, 3 phase. Single phase 240 volt. Okay, all right. So this is the example of communication system. Janji nak habis. Okay, kita berhentilah kot. Ada banyak lagi ni lah. Satu lagi lah, last one. Pasti baru masuk yang ini kan. Electrical quantities and units. So, maksud ini last. Okay, so this is the example of communication system. So again, this is also electricity lah. Uses electricity form of energy. Okay, we have communication satellite here. Okay, this is the transmission antenna and receiving antenna. So this might be apa ni Johor. This might be your house lah. Tak kira lah mana-mana dengan Kelantan, KL ke. Okay, so this is how it's work. So your telephone and then switching center, coaxial cable, wave station, and then we have a transmission antenna, and then at the end of the receiving, we have a receiving antenna. So this is how it's work lah. And it can be, the receiver can be transmitter as well. So that's how it works. Okay, all right, that's it. Thank you very much for your kind attention. We might have your next class afterwards, right? So let's stop dulu. So in the next class, we're going to discuss about apa tu